Welcome to my YouTube channel Physics with Rana Mudassar. Subscribe, like and share. Welcome to second video of photoelectric effect lecture part 2. Here are some contents of my presentation here. First of all, we will discuss about photoelectric effect and its experimentation, and furthermore we briefly discuss that what is the experimental setup for photoelectric effect and the purpose and the functions of different components that are used in this setup. Furthermore, we will discuss here very two important terms that we use throughout this lecture. That is, first one is threshold frequency and stopping potential. Furthermore, the main part of this presentation is here we will discuss about the relationship between frequency, stopping potential and frequency, and other. We also see the relationship between the intensity and in maximum energy of emission of electron and the frequency of light. Main we will discuss about these parameters: frequency, stopping potential, maximum energy of emission, and intensity, and how these terms are related to each other to define to elaborate the photoelectric effect phenomena. At the last, we will also hear another property, that is how intensity and photoelectric current are interrelated to each other, and what is the trend they show that if we increase the intensity then photoelectric current increases, but what will the effect on the other quantities such as frequency and stopping potential of the metal surface from which electrons are emitted through photoelectric emission. Photoelectric effect experimentation. Here we will discuss about the experimental arrangements that will be conducted and assembled to produce photoelectric effect and to observe this phenomena. Here's a experimental setup for photoelectric effect. Here we have an evacuated glass tube that contains anode and cathode, and across which we have connected a voltmeter, and also in series a ammeter. Here voltmeter 2 is used to measure the potential difference between anode and cathode, and ammeter is here used to measure the electric current through the circuit, and across it we have connected a battery. Here battery is connected to provide potential between anode and cathode of the circuit. Now here the rheostat. Here rheostat, we know that it is an electrical device that is used to control the electric current through the circuit by varying this resistance. Now we will discuss these components one by one here. First of all, here is evacuated glass tube fitted with anode and cathode plate in it. Here anode and cathode that is fitted in this evacuated glass tube. Second, we have connected here a battery for providing potential, because positive and negative potential are provided between anode and cathode to flow the electrons from anode to cathode, so battery is used for this purpose. Voltmeter. Here voltmeter is used to measure the potential difference between anode and cathode, and ammeter we discussed earlier that it is also used to measure. We know that in series in circuit to measure the current flowing in the circuit. And here also another component, rheostat. We know that it is an electrical device to use to control a current by varying resistance. And at the last, here is the phenomena of photoelectric effect, that when a light of suitable frequency, this suitable frequency is called threshold frequency, that we'll discuss in detail in the next slide. Suitable frequency is allowed to fall on anode, and photoelectrons emitted from the metal surface move towards cathode due to the potential difference that is actually here provided by this battery. So here's a phenomena in which photon light streams and falls on the anode, and anode is the any metal surface, and electrons from the metal surface are emitted, and it will move towards the cathode, and it will move towards the cathode due to the potential difference between anode and cathode that is actually provided by this battery in this diagram. Some important terms here we will discuss. First one is threshold frequency and stopping potential. Here is the experimental setup for photoelectric effect, and first up we see that what is threshold frequency: the minimum frequency of incident light below which no photoelectrons are emitted, however intense light may be. So this minimum frequency is the limit, and if we have a frequency that having value below this minimum frequency, then photoelectric effect cannot be observed. So in order to observe photoelectric effect, this minimum frequency, which is also called threshold frequency, should be achieved. And the second is stopping potential. What is stopping potential? The retarding negative potential for which the photoelectric current just becomes zero. So if we provide negative potential at the cathode and electron will not reach at this plate of the cathode, so this minimum retarding potential which retard the electrons to reach at the cathode is called stopping potential, and this stopping potential is also called cutoff potential. Relationship between frequency and stopping potential. In this slide we will discuss that what is the relationship between frequency and the stopping potential. When instant light of same intensity and different frequencies allows to fall on the metal surface, then what will happen? Here from graph we see here that if we the frequency is different and then stopping potential will be different. So for different frequencies of instant light corresponds to different values of stopping potential, and if frequencies are in increasing order, then stopping potential will also be in increasing order. It means that if we have a light of higher frequency, then we should have required a higher potential stopping potential for that metal surface. If frequencies are order, if we hear the frequency f3 greater than f2 and f1, then correspondingly we also required a higher potential difference accordingly, which is v3 greater than v2 and v1. The basic reason behind this is that if we look at this equation, that E is equal to hf. Here is the energy, h is the Planck's constant, and f is the frequency. We see here that here is a direct relationship between energy and frequency. So greater the frequency, greater will be the energy, and it will emit a photoelectrons of high energy, and in order to stop these photoelectrons to reach at the cathode, we should require a higher stopping potential so that it will not reach at cathode. So this is the basic reason that why we required high potential difference for high frequency of light incident on the metal surface. Effect of frequency on stopping potential. Here we will discuss what is the effect of frequency on stopping potential. Here is a graph showing stopping potential on y-axis and frequency on x-axis. Here the trend shows that we got a straight line and that cuts the frequency axis or x-axis. If graph is plotted between frequency and corresponding potential, then for any emitting surface we got a straight line which is not passing through the origin. Here the straight line which is not passing through the origin is showing that we should have a specific frequency. After that we got starting the photoelectric effect, and below this frequency there is no photoelectric effect occur. The intercept of frequency axis gives this minimum value, and this threshold frequency is different for different metal surfaces. This minimum frequency is called threshold frequency, and below this specific frequency no photoelectron emitted how much intensity of light. Maybe if we increase the intensity of light more and more, if we could not achieve this specific frequency, then the intensity of light does not mean that it will occur the photoelectric effect, but this threshold frequency is always required and is the necessary condition for photoelectric effect to be occurred. Relationship between stopping potential and intensity. Now we will discuss what is the distance between intensity and stopping potential. What is stopping potential? Stopping potential is also called cutoff potential, and it is the minimum retarding potential at which photoelectric becomes zero. So what is the relationship? That if we look at the diagram here, that if we have a light of intensity I1 and intensity high intensity I2, and we here observe that the stopping potential is same for intensity low and high I1 and I2. The relation between photoelectric current and retarding potential here, and it concludes that the stopping potential is independent of the intensity and of incident radiation if frequency is kept constant. So if we have a light which is varying in intensity I1 and I2 but having same frequency and falls on a metal surface, then the stopping potential will be same for both intensities of light. Here the reason is that increasing intensity, it means that just that there is an increasing number of photoelectrons, and as a result if photoelectrons are emitted increases, then photocurrent increases. Here we show that here I1 is having a low photoelectric current and I2 has showing here a larger photoelectric current, but the stopping potential here is same for I1 and I2. So it's mean that if we increase the intensity of light, then it means that only photoelectric current increases, but there's no change in the stopping potential of the metal surface. Now we will discuss relationship between intensity and photoelectric current. Here's a graph which is drawn between intensity of incident electromagnetic radiation and photoelectron current. Here's a straight line which is showing that intensity of electromagnetic radiation incident on the metal surface is directly proportional to the photoelectron current. Photoelectric current is directly proportional to the intensity of incident radiation, and here's a graph, always remember that this is at this condition when photoelectrons and intensity of incident radiation are directly proportional to each other, the other two quantities, frequencies and accelerated potentials, are kept constant. The intensity of radiation can be changed by changing the distance between anode and cathode. If we change the distance between anode and cathode, then the intensity of the incident radiation can also be changed. Here's the conclusion that if we have a photoelectric current which is directly proportional to the intensity of instant radiation, then it's mean that the higher number of photoelectrons that are emitted from anode and reaching at cathode due to the high intensity. So as a result, photoelectric current is increases in the circuit. In the upcoming video, we will discuss about classical approach to photoelectric effect, and there we will discuss that why electromagnetic theory fails to explain photoelectric effect. Furthermore, quantum approach to photoelectric effect, and this is actually the approach which is given by Einstein, and he also got Nobel Prize for this elaboration, which is Einstein theory about photoelectric effect and Einstein photoelectric equation. And at the last, we will discuss about some real life examples of photoelectric effect, and we have a question answer section and quiz section at the last of this lecture.